In this video, we're assuming you have the principles of probability down, and so we're going to put those principles into practice with some problems. And here's our setup. We're going to suppose we have a deck of 30 cards, and there are three, we can call these suits, blue, red, and yellow. And in each suit, we have 10 cards numbered 1 through 10. We're assuming the deck is thoroughly shuffled throughout this process. We're going to investigate 4 questions. With one draw, what's the probability that the card is a 3? What's the probability that the card is a 3 or a 7? And third, what's the probability that the card is a red 7? And then we'll have 2 drawn cards, and we'll keep both of them, and calculate the probability that we have at least one 3. So first problem. We have our deck of 30 cards. We want to know the probability that the card we draw is a 3. So that's what we're looking for. We want to get a 3. So our hypothesis is the card is a 3. And we have some evidence here. If we want to put that in, the evidence is that we have one card drawn. And in this case, there are 3 3s. And so that's 3 out of 30 possible cards, or 1/10, or 0.1 is our probability. Okay, second scenario. What's the probability that the card is a 3 or a 7? Our hypothesis now is that the card is a 3 or a 7. We're still assuming the same evidence, same situation. We're just going to draw one card. Now, in this case, the probability is determined by rule 3. So we're going to need to add our numbers together. We have 0.1 plus 0.1. That's 0.2. Third, what's the probability that we have a card that is a red 7? So that's what we want to get. This is a rule 4 scenario because we have 2 things we need to get, 2 hypotheses that must both be true. First, the card must be red, and second, the card has to be a 7. So we can multiply the individual probabilities in this scenario. So we need to calculate the probability that the card is red, and that's going to be 1 over 3, one red suit out of 3 possible red suits. So that's 3, 3, 3. And the card is a 7 is 0.1, and so we have our answer 0.033. Now let's draw 2 cards and keep both of them. Here we're going to calculate the probability that we have at least one 3. Now we can't use rules 3 or 4. Neither one are directly applicable. 3 is not because we don't have an exclusive disjunction. We could get a 3 on the first draw and a 3 on the second draw. And so we don't have a rule 3 situation, right? Whenever a situation involves a disjunction that is not exclusive, we have to use the theorem. And when we're using the theorem, we first calculate the probability that neither card is a 3, right? The negation of our initial hypothesis. So the first card's not a 3, and the second card's not a 3. And then we're going to subtract that from 1, and that'll give us the probability that at least one card is, in fact, a 3. So how do we do this? Well, we calculate the probability the first card's not a 3. We multiply it times the probability that the second card is not a 3, and that's going to be 27 out of 30, 26 out of 29. We get our 0.807, and we get our answer after we subtract it from 1, right? 0.193. That is our answer of the question, at least one card is a 3 with 2 draws.